This is a brief video on multiple regression in Simetar. We're going to start with a data set that has 21 observations in it, a y variable we'd like to forecast, a series of 4 x variables, x1, 2, 3, and trend, and we have some assumed values here for our future periods that we'd like to forecast, or they might just be 3 alternative scenarios we'd like to test for our model. To run a multiple regression in Simetar, you click on Simetar and select the icon multiple regression. It brings up this menu. You highlight the y variable. You highlight your x matrix, and it has to be contiguous. We can't have x's here and there across the spreadsheet. I want to select all of the different pieces of output or types of output that we can get from Simetar. I will note that there are 7 different ways of running multiple regression in Simetar. You can use ordinary least squares, generalized least squares, logit, probit, ridge, 2-stage least squares, and weighted least squares. We're going to use OLS today. Click OK. We get this output. Now I'm going to widen these columns so we can see our output a little bit better. We have, in this case, several variables. We have 2 of them that are statistically significant. We know this because the beta coefficients and their labels are in bold. X1 and trend are in bold. They're statistically significant at the 95% level. You can also see this by examining the p-value. Now, the other 2 variables, x2 and x3, theoretically should be included in this equation, and they're being masked by the presence of this variable trend. So I'm going to rerun the regression without trend. I happen to know this because I created the data set. Now if I run the model without trend with normal Excel functions, I'd have to completely rerun the model. In Simetar, I just simply type in a 0 here in the restriction row, and it refits the regression without the presence of the variable trend. How about that? We could restrict out, test what happens if we take out another variable, such as x3. That's not as useful. That actually lowers our r-squared from 90. And if I put this back in by removing the 0, I've increased the r-squared back to 93.9. Now how does that compare to the unrestricted model? When we first start out with the unrestricted model, we have an r-squared of 95.3, F ratio of 80.99. With the restricted model, we have 87.46, so we've improved the F ratio. We've reduced the r-squared because we dropped a variable out. The r-bar square has reduced slightly, again because we reduced a variable. The key information criteria has increased as we would have expected. We have a covariance matrix of the beta coefficients. Okay. We have a projected set of values here for y, the predicted y's, y hats under most circumstances, the actual values for y, and the residuals. We have standard error of the predicted y, and the model is capable of updating itself if we happen to change the x values. For example, observe what happens to the beta coefficient on x3 if I had inadvertently typed this number, this value for x3 incorrectly as, let's say I typed it as 9.733. It causes all of the beta coefficients for the model, all of the goodness of fit test, to change when I have an error in that number. If I correct that value, okay, it updates all of the coefficients in goodness of fit statistics. This could happen by changing any value in the X or the Y matrix. Okay. Now, we have a set of forecasted values here. We had an assumption of what they would look like. And this red line here is the forecast for the last 3 periods. Now, it's actually a stochastic forecast, and if I press F9, those numbers change. How are they changing? Well, let's go over here and look. If we come down to the output to the forecasted values, this is the forecasted mean for our assumed values here for scenario 1, 2, and 3. Okay. This is the forecasted mean, the y-hat. This value in bold is the stochastic forecast. And what it does is use the normal probability distribution, taking the mean predicted value, the predicted y-hat as the mean, and the standard error prediction for y as the standard deviation. We can actually simulate this, and I'm going to give it a label here. So we'll have S1, S2, and S3 as our labels. I'm going to simulate these values by going to Simetar, click on the Simulation tab, tell it that the label is on my left, add this list of 3 variables to my output list, and click Simulate. And I instantly, or in less than a full second, get 500 simulated values for my 3 scenarios. And there are the 500. We have some embedded formulas here at the bottom of the sim data that will give us probabilities. And let's just ask, what's a probability of our forecasted value being less than 1700? And it says it's 2%. Okay. What's the probability of it being less than 1800? And it says it's 25%. So there's a 23% chance that our forecasted value in scenario 1 is between 1700 and 1800. What's the probability of it being less than 2000? It's 97%. We could drag this same formula, these same numbers across here, like that, and check the probabilities as we go. It's also very useful to draw a probability density function of our simulated values. Okay. Continuing up here to the top of the page, we'll draw a probability density function and then a cumulative distribution function using the Simetar commands. So we go back to the Simetar word, the graph tab, probability density function. We can draw a probability density function for all 3 variables by just simply highlighting the label and the data. Click Add, and OK. And we have 3 probability density functions there. It's simply an Excel function chart, so we can edit the axis if we'd like. We can make that 1500 for the minimum, and see what that looks like. Sure, that looks a lot better. Okay. Now, what if we would like to see a cumulative distribution function of these same variables? Again, Simetar, graphs, CDF will highlight the 3 value variables. In this case, they're variables. They are our forecasted values for 3 scenarios. Click OK. And over here on the right is our CDF chart. One more time, if we want to reformat that x-axis so they don't lie so much on top of each other, we can change this to say 1500 and click that and see what it looks like. Good. That's an acceptable chart. Now, we can come back to our original data and run another scenario. What if we wanted to find out in scenario 3, what if x2 was 2,000? Okay. Again, we'll just go back and simulate this new set of scenarios. We've already identified our key output variables to send over to SimData, and we'll just click Simulate, and voila, it re-simulated it. It definitely shows that scenario 3, if x2 was 2,000 instead of 1,900, it definitely increases our mean and the whole range of the distribution, shifts that distribution to the right, and we can also see it in the CDF. There's one other thing in the regression output that's quite useful. And this is called the DF beta section of the output. And what it does is we can use these studentized residuals to identify outliers in our data. We have an outlier at observation number 17. And one of the ways of statistically dealing with outliers is to dummy out that observation. In other words, rerun the model with a dummy variable. Well, Simetar allows you to do that interactively by putting in a 0 here for observation 17 for its restriction. And when we do that, you'll see that it increases the R square. This R square had originally been 0.939. Now it's 0.959. So we increased the R square. And we've still got our capability of simulating it. But what we've done is taking out the adverse effect of the outlier in period 17. Now I'm going to re-simulate this model, and we'll see what the results look like. Simulate, and they look about the same as we had before, but we think we should have a more statistically reliable result, given that we've got a higher R square and a lower standard error than we did before. It's interesting to note here that in Simetar, point out the feature, that the charts are instantly updated when you simulate again and place new data in these columns of simulated values. One thing it does is it takes out these formulas that we had below, where we had the probability of it being less than, say, 1,700. That's a minor inconvenience that could be overcome by simply copying these formulas or dragging these formulas to a safe location on the spreadsheet. Then the next time we simulate, they'll be where we want them, and they will be updated automatically. If you have questions about this, you can always contact me at james@simetar.com. One more thing we would like to say is show you what the scatter plot does. The scatter plot is a neat feature that's in Simetar. It allows you to look at the relationship, plot by plot, relationship of y variable versus any of the x variables. So this is what the relationship between y and x2 is. Relationship between y and x3 looks like this, and between y and trend looks like that. And you can, of course, return back to the default of x1. Thank you very much.